Good morning, 7th grade. Welcome to day 3 of week 5, April 22nd. So I'm just going to take you through what you're responsible for today. So we'll go to our classwork tab. We'll go to week 5, day 3. You have your lesson for today. So our lesson is focusing on identifying if a graph is proportional. So you have your lesson, and then there's also a link provided just as an additional resource. It goes over what we're reviewing in the lesson, some of what we're reviewing in the lesson. So it's there for your assistance. All right, so the lesson starts off with a table, and I ask you if the table is proportional and to explain why. So I just wanted to show how we would figure this out. So you want to check for those two things. If your table has a constant, and if it includes 0, 0. So there are two ways we can figure this out. We can do what we've been doing, which is finding that change in y over the change in x and see if it comes out the same. Or you could have done option 2, which was checking for that constant y over x being the same. So I'll show both so that you guys can see that, but I'm going to start with this one. So we're checking if the change in y over the change in x comes out the same. So I'm going to start with my y's. So here I see that it's plus 3. From 3 to 6, it's plus 3. So I'm going to start with 3 over 1. Oops, I jumped ahead. 3. And then for the x, from 1 to 2, it's plus 1. So my slope, or my constant, is going to be 3 over 1 for the first one. Now, some of you are getting confused with this, and that's what yesterday's lesson was about. So please go back and review that lesson if you're still a little confused, because I noticed that some of you were seeing these numbers jump and automatically saying it wasn't. But if you look, from 6 to 18, we're changing by 12. So that's our change in our y. So we're going to do 12 over. Our x's from 2 to 6 are changing by 4. So we have to check this ratio, 12 over 4. 12 over 4 simplified would also be 3 over 1. So far we're still constant. We're good. And you have to do that for the rest of the table to make sure that it keeps coming out to 3 over 1. So from 18 to 36, it would have been plus 18. Okay. And then from 6 to 12, it would have been plus 6. So we would have 18 over 6, which again reduces to 3 over 1, so we're still good. And then this last one was a big jump. I already did the calculation. So from 36 to 60,000, it would have been plus 59,964. So that's I'm gonna put that here. Over the change in the x from 12 to 20,000 would have been plus 19,988. Okay, so I just did this minus that to figure that out in case you were wondering. So I'm going to put that here. Oops, 88. And believe it or not, when this one's simplified, it also comes out to 3 over 1. So we can say that yes, there is a constant. Okay, the next thing you have to do is see if 0, 0 is in my table. So you use the simplest constant to check that out. So we're going to use 3 over 1. So I'm going to reverse adding 3 to my y's. I'm going to do the opposite and subtract 3. Okay, because we're moving backwards in our table. So that would give me 3 minus 3 is 0. So far that looks good. We get the 0 and the y. Let's inverse the x now. My change in x was plus 1, so I'm going to do minus 1 instead, and 1 minus 1 gives me the other 0. So this table would include 0, 0. It's not there, but it would be there if we move backwards. Some of you are skipping that too. That is what yesterday's lesson was on. So those two things you really need to go over if you struggled with any material from yesterday. So because it has a constant, because 0, 0 is included, we would say yes, this is proportional. Okay? Some of you were using the second option, which was checking for a common ratio between y and x. You could have also done that and seen that the same thing would happen. So if I look at my y, it was 3, my x is 1, so right now it would be 3 over 1. If I check the second one, it would have been 6 over 2, and 6 over 2 equals 3 over 1. Remember, you can only use the strategy of checking for proportionality. Okay? The third one, 18 over 6. Same thing, 3 over 1. And it would have worked for the other two as well. Okay? So that's just another strategy. If you prefer to use that to check if a table is proportional, you absolutely can. All right? So that was the review of yesterday's lesson. It is your warm-up for today. You'll see the answer is a little vague because you guys should be familiar with this at this point. So it just says yes because there's a constant of 3 over 1 like we just saw, and 0, 0 would be included if he moves backwards. So we're going to focus on the graphs today, and there are two things you need to know for a graph to be proportional. The two things are it must be linear and it must pass through the origin. So the one on the left we're going to say is proportional because it's linear, which means it's a straight line, and it goes through the origin 0, 0. The one on the right we're saying is not proportional because yes, it's a straight line, but it does not go through the origin, so this is not proportional. So to start, that's all you need to know to figure out these questions that are going to follow. See, proportional, linear, we have, and it goes through the origin. We can use the equation y equals kx when it's proportional. We can say that there's a constant rate of change. You could also call it a constant of proportionality. Here, it's not proportional. It is linear, but it's not proportional. Why? Because it doesn't go through the origin. So when it's just linear, we use the equation y equals mx plus b, which we were practicing earlier this week, okay? So then we have this graph. You're going to do your two check fors. That's what I called them. Is it linear? Does it include 0, 0? And then you state your conclusion. So looking at this graph, is it linear? Yeah, because it's a straight line. Does it pass through the origin 0, 0? Yes. So we would say, okay, this graph is proportional. The two check fors are met, so we say this graph is proportional. Go to the second one. You keep doing the same thing. Is the graph linear? Yes. Does it go through the origin? No. So for this one, we would say, no, this graph is not proportional. Both need to be satisfied. Okay? So you have a few more to practice. And then after that, we're going to now, if the graph is proportional, I'm going to ask you to find the constant. So it's the same thing as finding the slope. You guys did this in class. Okay? You just got to like think back to when we were there. I know it's been a while. So I have that same graph that you see on that slide here. I just feel like it would be easier to see it, you know, on the bigger board. I skipped here just to space it out since I only had limited numbers, but it doesn't really matter. Okay? So what you want to do to find the constant, most of you should remember this. The first thing you want to do is find two nice points. Okay, so two nice points mean that they fall right, oh, that was terrible. They fall right in the corner of these boxes. It would be very easy to identify the coordinate. We don't want to get a point that's kind of like floating in between, okay? So I'm going to look for two nice points. I'm going to take this one because it's my origin, so I know what it is. And I'll just take the next one that follows it right here. Okay? So once you have those two nice points, you want to find the rise over the run. Some of you might be remembering this. The rise is how many up or down, and the run is how many to the right. So we go to our graph, and although this looks like it's only two boxes, we have to use the numbers on the box, on the graph, to figure out what that distance actually was. So we're going from 0 up to 92. So this rise is plus 92. Not plus 2 because there's two boxes. It's plus 92 because we went from 0 up to 92. So this increased by 92. So right now my rise is 92. I'm going to put that here. And it's positive because we went up. Okay? Then you count, okay, what is my run? So from here, from the 92, I'm going to see how many did I move over. So I was at 0, and now I'm at 2. So I ran over plus 2. So my run is 2. and that's going to be our slope. But you always want to simplify if possible. So I know that these two could definitely be simplified because they're two even numbers. So I have 92 over 2. I'm going to divide them both by 2, and that would give me 46 over 1. And this should be your final answer. Okay, so that's going to be our constant of the graph. Is this graph proportional? Yes, because it goes through the origin and it's a straight line. So when our graph is proportional, we call that constant K. We use a different letter to identify that this is not only linear, it's proportional. So K is going to be 46 over 1. And then the only other thing that you should do is relate that slope back to the problem. So the 46 was talking about the y, and the y was talking about the distance from home. So this means we would be 46 miles from home in, let's see, the x was talking about hours. So if it's 1, we would say in 1 hour. Okay? So let me take you through that again. We were given the graph. The first thing you wanted to do is find the two nice points. That was this one and this one. We then decided, okay, let's figure out what the rise and the run is. How many boxes or how many units? What's the amount that I'm moving up or down? And then what's my run, which is always to the right. So here our graph was counting by 92. I went from 0 to 92, which means I rose up 92. And then I ran from 0 to 2, so my run was 2. So we got 92 over 2, and then that would simplify to 46 over 1. You always want to simplify your constants, okay? Then we said, okay, well, since this graph is proportional, then I can use the letter K for my constant. So my constant is 46 over 1, and then we just relate it back to the problem. The 46 would be representing the distance from home, and then the 1 would be representing the hour. So we would be 46 miles from home in 1 hour. Okay, so the lesson shows you the same thing I just modeled. It reminds you should always be in the form y over x. Okay, there's some steps for you. Basically just finding that slope, simplifying it, and relating it back to the problem. There's a few more examples for you to try again. The answers are on the following slides. And then the only other thing that we're asking you to do is the Google form, your exit ticket for today. So I'm going to X out of this so you see it. That would be right here. You click on the Google form. I believe it's 6 questions. Let me see. Well, it comes out to 10 points, but you're answering 6 questions, and 4 of them, I think you are describing, like, how did you know, okay? And that's it. I hope it was easy. Remember, the 2 takeaways for today. How do you know if a graph is proportional? It needs to be linear and go through the origin. How do you find the constant of a proportional graph? You find those 2 nice points, you calculate the slope, you simplify it, and then relate it back to the problem. Have a great day. Talk to you tomorrow.